Hello guys, welcome to Cafero at Simplify. So we're gonna do this on sharp. Reason being they are similar to this content. Just that here we're maximizing, here we are minimizing. And minimizing, that means the derivative, the second derivative should be greater than zero. And so when we are given this one, first differentiate the first time. When we differentiate this, it becomes 24 plus q, 2q, because this 2 drops here. Now equate this to 0. When we equate that to 0, we find the value of q. Q is 12. Differentiate the second time, we differentiate this one, we get 2q. Now since this one we get is greater than 0, this shows that q corresponds to a minimum, because we said the second derivative should be greater than 0. This means this value here, the 12q corresponds to a minimum. And then we come to our second one, which is actually I think we are going to do this other one to can go through it. Then we come to this. A third, it has a negative. That means we'll be getting a different answer. So do the one which has a negative. Let me explain this, and you do the one which has a negative. Okay, so we are here. We are minimizing. The question is okay. I was confusing it with the up one here for a negative. So we are just having actually the same thing. We are having this when we have to minimize this, differentiate the first time, these 3 drops, this 2 comes and multiplies with the 4.5, get 9. This becomes 14. This one runs to 0. Fine. Solve the equate to 0, solve the quadratic equation, the critical values, you get this and this. Now find the second derivative. After finding the second derivative, put these 2 into your equation and see. This gives us 5, which we want, because when we are minimizing, the second derivative should be equal to 5. This means the value we have put here, which is 7, is the critical point. We shall get a minimum. So now we go to the last one. A third q squared minus 8 this plus 60q. Same thing. First find the first derivative. This drops, 3 cancels with 3, we get q squared. This drops, multiplies here. This cancels, we remain with this. Now equate to what you've got to 0. Solve the quadratic equation, and when we solve the quadratic equation, get the 2 critical values. After getting the 2 critical values, differentiate again. We're differentiating this one, which we've got after the first derivative. We differentiate now this one, so we get 2q minus 17, which is here. Now put your 2 critical points inside. Find which one gives you positive, and that is the relative minimum. And so we come to our last two, these last two, before we come to price elasticity. Now these last two, they are saying given a farmer's demand is this equation, q minus 90 plus 2p equals to this. Find its average cost, and its average cost, and this is the average cost. Find the level of output. And that's the reason why I didn't write it down or on a computer myself, because when this is what it brings, they look weird. So I had to use this so that it writes there very well again. Yeah. Find the relative, find the level of output. So whenever they say find the level of output, they want Q, which maximizes. Whenever we maximize, the second derivative should be less than 0. The total revenue minimizes marginal cost and all this. So let's dive into this. The level of output that maximizes total revenue, the level of output that maximizes marginal revenue, and the level of output that maximizes profits is what we are looking for your case. So express this. Now you realize this is the equation which we have, but we don't have TC equals to this, or TC equals to this, or TR equals to that. So what we do, make P the subject of the formula. Take this on this side, take this on this side, then divide by 2. After this, we get, to get total revenue, we get P times Q. So if you have 45 minus Q over 2, Because when you get 90 over this, it's 45. That's what I think we are going to have here. 45 minus 2 over q. And when you multiply with the q, here we have 45 minus q over 2. So when we multiply with the q, we come to, okay, they have retained the half outside. I wanted to do it at once. So when you divide this, I don't know if you are getting the whole point. We have this equation, which is here, which is our P times Q to get the revenue. So we have this whole equation. So they have extracted this half outside and they have maintained this inside. So that means that we get a half times 90 minus 2q. So this q becomes 45. Equate this multiplies 0. So when you equate this to 0, q becomes 45. So the level of output that maximizes revenue, q is at 45. So then marginal cost and minimizing it. So SC, marginal cost is MC, and the marginal cost is the derivative of the total cost. I think we mentioned that. Since we have SC and we want MC, what do we do? We have this equation which is given, though you're seeing it. So when you multiply by Q to find the total cost, when you multiply this by Q to find the total cost, Q, because total cost equals to SC, average cost, times quantity. So when you multiply inside, Q increases and here Q reduces. And now we come to find the marginal cost of, now if we have TC, we can find MC by differentiating this whole thing. We know how to differentiate. This drops down, this comes here, this one remains the way it is. Then we find, to find the level of output that maximizes this, take the derivative of MC and set it to 0. Equate this, equate the derivative, differentiate again. When you differentiate again, the second derivative, this becomes minus 16. This is 6. Equate it to 0. So this part is this Q, which gives us the maximum quantity of marginal cost. Then we come to the last part, and let's handle the last part in the next video.